All right, so now we will discuss how the vertebral system is entering and what are the two terminal branches. The basilar artery will divide into two major branches. So again, right vertebral system, left, they merge together at pontomedullary junction, goes up and form basilar artery, okay? This is basilar artery. And basilar artery we also give some branches to pontine area, that's the pontine arteries. And then the basilar artery will divide into two terminal branches, and they are posterior cerebral artery, posterior cerebral artery, okay? So they supply blood to the posterior part of your brain. Again, now we saw the system here, the internal system is communicating with each other using anterior communicating artery. Now these two systems, vertebral system and internal carotid artery system, wants to communicate with each other. How will they communicate? Here is the posterior communicating artery connecting with posterior cerebral artery here. So that's how they communicate. Hit your pituitary gland. Ignore my drawing, actually, it's not good. Okay, so you see that vertebral artery comes up, divides, merge together to form a basilar artery. Basilar artery then divides into two terminal branches, posterior cerebral artery, which is PCA, and posterior cerebral artery. Now the posterior system will communicate with the anterior system. How they do it? Using posterior communicating artery. Now posterior cerebral artery will communicate with the internal carotid artery system with the posterior communicating artery. And both anterior cerebral arteries are communicating with each other with anterior communicating artery. So this is a circle. We call this circle of Willis. It consists of posterior cerebral artery and internal cerebral artery, anterior cerebral artery, anterior communicating artery. So just familiarize yourself with the structure. All right, so just quickly I'll review it again. Again, this is a structure. I'm going to show you the circle of Willis. Internal carotid artery divides into two terminal branches, MCA goes laterally, anterior cerebral artery. Again, lateral one is MCA, middle cerebral artery, ACA. The anterior cerebral system and anterior cerebral system, how are they communicating? They're communicating with the anterior communicating artery. Okay, these two systems are communicating with the anterior communicating artery. Now the posterior system and anterior system wants to communicate again together. So how will they communicate? Using, so there's a branch coming out of internal carotid artery, goes to posterior cerebral artery. Posterior cerebral artery. This is posterior communicating artery. This is posterior cerebral artery. Posterior cerebral artery. Okay. Now this ring is called circle of Willis. It's a way for internal and posterior system to communicate with each other, and there's a very important purpose for this. Is because if there is any occlusion or any blood clot, or let's say there's an occlusion of artery right here, of posterior communicating artery, what happened if there is no posterior communicating artery right here? The posterior cerebral artery, we cannot supply blood to the side of the brain. So what happens? So the blood travels. So the blood travels from here and supply the blood to the side of the brain, so the brain tissue don't die. So that's the purpose. If there's an aneurysm or there's a blood clot, and some part of the brain gets blocked, if let's say this side of the brain, this side of the artery is blocked, blood cannot pass from here, but the circle of Willis is very unique. So blood will supply from here, goes here, enter, and supply the area which anterior cerebral artery was applying, providing blood. So that's the purpose of circle of Willis. Very important structure, and it is located in the subacromial space.